Hello everyone, in this exercise of the SolidWorks we will create a sheet metal cone. This sheet metal cone will we will create a revolve boss base of the cone with the help of the thin feature, then we will convert into a sheet metal part. File, new part, okay. This is the SolidWorks user interface. I am selecting the plain white and this is the millimeter gram second unit system is this. I am selecting the front plane, sketch, draw a line, this one. Okay, this is, I am making the construction line. Okay, line, and this dimension, firstly I will create a relation between this, and this 50 horizontal. Okay, this point, relation horizontal, this one, dimension, this dimension is the 12.50. This dimension I am taking 75 mm. Okay, this dimension I will take the 150. You can take the dimension as per your requirement. This one, this is the sketch is fully defined. I am revolving it with thin feature. System is asking, sketch is currently open. Would you like the sketch to be automatic? No. If don't want, close it. I want this one. But I am taking this angle is 359 because there should be a gap between the edges for creating the sheet metal part. Thickness is I am taking thickness 1.50. This one, and you can take the thickness inside or outside from here. This one, this I am taking inside the thickness. Sheet thickness is 1.50, 359 angle, and gap is between the two edges and edges is 1 degree, and the center line is automatic selected. This one is but this part is still a solid part. This is not converted into a sheet metal part. First I give the appearance from here, appearance, this one, this edge, this one, close it here. So this is a solid part. I want to convert into a sheet metal cone. How I will convert it? Go in the sheet metal, there is a command insert bands, select it and select any edge. This one. This size radius is 1.50. Minimum radius of the sheet should be 1.50 if the thickness is 1.50 or more than that. This one. Auto relief I will not require. And now this part has been converted into a sheet metal. Suppose you want to create the hole on this. How I will create? First I will create the future plane. First I will create the plane. This one. I will select a plane, front plane, this surface. I am selecting this face. But I am reversing the direction. Reversing direction, second face, this one. And flip side, this one. This one. Select this face. Now a sketch. I am taking a line, center line. This one. Okay. I am taking a circle. This dimension from here to here, 20 mm, and this dimension is taking it the 6 mm. This one. I will make the extrude cut surface. Sorry, sheet metal, extrude cut, link to thickness. Link to thickness. If I click OK, but there is an error. How will you remove it? From condition, you select the surface face plane, this one, and select the inner face. Okay, extrude cut will start from inner face and change the direction from here. Now it outside. Now cut hole is created. Future, go in the circular pattern, this one, direction, this one, and this takes place, 6 taking place. If I take geometry, this one, this hole are created. But we can't make the linear pattern of the first extrude cut because this is a circular face. You will have to create another hole and then we'll convert into the circular plane. For example, this one, sketch, and show. Select this line, this line, this line, select this line, convert entity. But this line, this lines. Make a hole, smart dimension, mm, this dimension 6 mm. Okay, sheet metal extrude cut, same thing, sketch plane, surface face plane, select the inside face, start condition from the inner face, direction change from here, and the second hole is created. This one, this hole is created. Again circular pattern, future, go in the circular pattern, go in the circular pattern, select future, direction is this one, okay. In this way, because we can't linear pattern of the first hole, because this is a circular face, so we will have to create individually holes and then we'll convert into circular pattern in this way. I did this one. Now how I can fold or unfold it? The sheet metal, there is a command unfold, this one. Unfold, you select any edge because there is no fixed face here, this one, and collect all bands, this one. Now it is a fold command. This one, if you want to fold, edge is automatically selected, collected all bands, this one, this is the fold command. Again fold it. Or flatten, you can flatten it. But in the case of the flatten, we can't edit the structure. So this part you can save in DXF format for AutoCAD for the cutting purpose, and this one, normal, front view, this is normal view, this one. How you can use save as DXF format. This is the default. Give flat button for save. The one window pops up for the sheet metal, and whatever the feature you required, you can select it. Hidden lines, band lines, and forming tool, no forming tool, bounding box. Bounding box means this outer boundary. This is the, and click OK. You can save it. You can give this file. This file is saved in the AutoCAD format, or DXF file for the for cutting purpose, because DXF file is applicable for cuttings in the CNC machine, etc. In this way we can save it. If you want to make the drawing for this part, file, make a drawing from the part, we can make it. File, okay, file this one, part save, we can part on with the hole, suppose. Save it. This one, there are different formats are available. You can select the required format. I select A3 for this one. This is the flatten view. I take is the flatten view. This one, you want to increase the size of this thing 1.5. 1 is to 2. This is the size, bigger size increases. Okay. And dimension from it 193 radius. And from here. Dimension you can. The radius. You can take the triangle. As far as the whole is concerned, you can make the whole table. Annotation, there is table, whole table, and x and y axis, or 0 point. This 0 point, edges or faces, this, 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 selected, and OK. This table comes. For a whole, this whole table comes here. So in this way, you can make the whole table for the whole. If you want to save it, you can save it. Save as TRW file, save it, save all. In this way, we can save the. In this way, we can take this cone in the sheet metal cone in the SolidWorks. I hope you would have enjoyed in this exercise. You please like, share, and you please subscribe this channel. Thank you for watching. Thank you very much.